Hey everyone, this is Derek, and in this video we're looking at finding x and y intercepts for rational functions. So just like any other function, to find an x-intercept we're going to let y equal 0, and then to find the y-intercept we're going to let x equal 0. So let me show you what that will look like in these, and these can definitely have some do not exist that, or does not exist that will happen. So here if we do, for this first one, let's let x equal 0. So when I let x equal 0, that's going to get me the y-intercept, or the f of x over here. I'm going to write it as y for a second just to make it feel more like a y-intercept. And so if you notice what happens, and this one I'll write out, and the rest of it I'll kind of shortcut. But basically, everything with an x drops out, and then your y-intercept is going to be that ratio that's left on the end. So here our y is equaling negative 3/5. So when x was 0, y is negative 3/5. And then to find the x-intercepts, we let y, or f of x, equal 0. And then let me show this with all its gory detail on this one, and then I will shortcut it as well. So here, what I would do next is I'd multiply both sides by that x squared plus 5. But you see what happens on this side is it's just a 0. So then up here, I have, in other words, set the numerator equal to 0 and solve. And that's all we got to do in these, because that denominator is going to cancel every time. So I can just do numerator to 0 and bring that 3 over, and I get x equals 3. So 3, 0 would be my x-intercept. For this next one, so if we let all the x's equal 0 to try to find the y-intercept, we get 0 over 0 minus 0, and that is undefined. So we do not have a y-intercept, because the only one that we get doesn't work. So for y-intercept, that is, it does not exist. And then for the x-intercept, I would let the y equal 0, and what I get is x equals 0, except that can't actually be the case, because we just set up here, if we let x equal 0, it messes up the denominator. So in this one, the x-intercept also does not exist. Okay, so for this one, if I let all those x's equal 0, you can kind of see the 7/5 on the end. So y-intercept, let's make that intercept, is when x is 0, y is 7/5. And then if I let this numerator equal 0, there is nothing that multiplies to be positive 7 and can add to be positive 1. That is not possible. And so in this case, the x-intercepts do not exist. Over here, let's see. So for the y-intercepts, x squareds would cancel. So for y-intercept, we're looking at positive 9 over 25. So that's when x was 0. And then setting that numerator to 0, 0 equals x squared minus 9. And that's just a nice little difference of squares, so we'll factor x plus 3 and x minus 3. So our x-intercepts are going to occur at negative 3, 0 and 3, 0.